Hey everybody, this is Brad Dyke saying hi, how you doing? And I just first wanted to say I hadn't forgotten about I'm going to make the smallest little NAS I possibly can make. And it's based on a Raspberry Pi style strategy. So I didn't want to do the latest greatest Raspberry Pi because that's not cost effective. And then the whole point of it was make something really cool, something different, something small, tiny. It's not about performance. And, how can we do that? I mean, how can we break the system, right? And get ourselves outside of the mold of, what the industry wants us to do. So basically, in a nutshell, we have to ask the question, what is that going to look like, right? We're going to make something small. We have to make it kind of conforming. In other words, it's got to fit a footprint, right? So I showed you some examples of some things like case housings, like this little guy right here, which is as you can see, it's a USB C to A output. It's got a small edge connector. It's got the plastic housing for the drive, and so on and so on. And then we also have, pigtail stacks like this. And, basically with that, you take, a standard, SSD drive, because it's non-mechanical. And, you're going to mate it and set it. And voila, you got yourself a tiny little thin. And, you could technically put these guys like this and put a couple on. And, but it's already too big. Seriously, if you look at it, for instance, let me give you an example of what I mean. If you take just two of these, like you see them, it's too much. When you put them like that, it's going to be bulky, right? You put the Pi next to it. This isn't going to work, right? Not if we're going to try to get serious about this. So I thought to myself, okay, so how do we get around that problem, right? How do I break the mold with what I can get my hands on? So what I thought was, what I would do is I would say, okay, this is all driven by standards. So what I did now is I took out one of these drive housing sets. It's got a drive houser here, and it's got the little insert, and it's got the the USB cable set. And I want to go ahead and just kind of set this guy up. And let me go ahead and prepare it real quick as I peel the protective coating off. And then this is supposed to slide open. I'll have to find which. There it is. And as you can see, it slides open. And we separate them. And we take a drive. Put it in. I do like the self-containment, which makes the fastening process better. But if you look at this, it's still bulky. Now, the good news is the adapter cable isn't bulky at all. Now, that's good news. So I'm looking at this guy, and this is it. You can't get any more basic than that. There's no adaptive bridging in there. Let me show you what I mean by adaptive bridging. This is this whole piece of plastic here. There's electronics inside here acting as the controller interface. Now, in this bus, the controller interface is right here. And that's okay. That's all right. There's nothing wrong with that. But having an external like this, it's bulky, right? So this guy, there is no standard here. This is as small as you can possibly make it. So this, on the other hand, not going to work. So how do we get around this problem? And, you start to, take a look at this. And people think standards. People can even kind of get scared, And they look at this stuff and they say, I don't know if I want to, do certain things with this warranty-wise. And, number one, most of the stuff we get our hands on, especially if you're going to be recycling old, for instance, you have the 4 or 5-year-old SSD 100 gig drives. It really doesn't matter about the warranty. And you know what? Frankly, I didn't pay enough money anyways on the standard. So I didn't have that expense, which was really important. By the way, I dropped this little guy right here. Sorry about that. And so I'm still looking, I'm still trying to find a way to do things in a certain way so I can accomplish what I want to do. Now, I'm also thinking about going outside the boundaries of, warranty support and things like that. So I'll explain that in a second. So here is where, here's where you go too far. So let me show you this little guy right here. I'm very impressed with this footprint because it's such a clean standing. Wow, that is just tiny as can be. So that guy is a little too small. So what does that look like? Well, in actuality, it's still a problem, mind you. But the base interface is, like this, and it is kind of a pain to put together here real quick. Yeah, it's got an L-stack style connector on it. And the problem with this is it requires too much connectivity on the front and the back, but it can eliminate that little piece on the end of the drive. Again, too big. This is our problem. So what do we do? Well, I'll tell you what I'm going to do. I am going to free this SSD drive. Now, what do I mean by free an SSD drive? Well, I'll show you. This is an SSD drive. This is plastic with an SSD drive in the middle. So, keep dropping things. What do we do? Well, I've already worked on this guy a little bit. He's got some heat sinks on it just to keep it in a cool kind of state. What I'm going to do is I'm going to cheat. And I'm going to take it way outside the standing being 2.5 inch drive configuration. That is, by the way, a format, an industry format to be exact. So all principal enterprise drives and standard compliant drives meet a 3.5 inch or 2.5 inch or bigger, if you want to talk age. But as you can see here is an SSD drive without the heat sinks. The heat sinks are just a minor, improvement. They don't really do great responses. You don't have to have heat sinks on it, but it does tend to help draw the heat out of the chip, so that's fine, but it's not necessary. So now we've got ourselves something here. So we have two SSD drives, right here, and they look pretty good. So, and I take my second smallest format. Remember, my very small format is just that. It's too small. Too much extra cabling is necessary to make it work. But this guy, all I need is a pigtail. And in this case, a very simple one. A C-class connector. And that's it. So that's pretty doggone small. But again, I have a new problem. And that is, when I set this up, there it is. It's a very small setup. That's really, really, really small, people. So you have to understand that SSD drives, 1 terabyte drives, aren't very big. But it's still in a 2.5 inch format. So what do I need to do here? Well, what I need to do is I need to free the chassis up so that I can use the chassis more intelligently. So to do that, I'm going to go to this. That's it. So I now have a SSD drive set up that is not conformed, is not a standard, but the boards are baseline, so that means I can put little tiny spacers in these holes right here, one here and one here, and I will be able to transform multiples of these on top of each other to give me my end result. So what I'm going to do now is I'm going to go ahead and open up another one of these, and I'm going to give you the attributes size-wise of how this drive is set up. And this will be just a RAID 1 pairing, RAID, NAS configuration. Here again, I have a brand new case housing. And I'm abandoning the 2.5 inch standard. And this will give me the ability to expand my horizons to a better detail and can reduce my form factor to a much more smaller format. And I don't think you can really get much smaller than this and still have a functional environment. So here we have two of these in a RAID 1 configuration. Look at how thin that is. That, ladies and gentlemen, is a very cool setup. Now I'm going to put some spacers in here that are wider than normal, just so that you can see the gapping. So let me get those real quick. Okay, and I've got different size spacers and stuff like that, but I don't want anything really big. And I wanted to keep it kind of conformed in the standing. So let me see what I can find here. I think I've got something here. Okay. This will work, I think. Okay, so I'm going to put a paired standing. This is the first one called a paired standing. And what I'm doing here is I'm going to put a spacer set in place. And I'll close that gapping down. So what I have is this. Can you see that? So this is my base. This is my gap. And then I'll take the second heatsink SSD drive and I'll put it on top of that, and then I can lock those down. So let me go ahead and get that finished here. Need more of these apparently. Okay, so now I've got my two standings, one on each side, as you can see. And then I'm going to put the next drive in place, and then I'll use another standing to tighten it up. Well, these might work better. Let me see. Yeah, let's do that. We'll use this instead. Give me two of these. And let's see if it works. Gotta make sure they fit first. Nope, they don't fit. So that's okay. And I will get the other ones because I do have those. Yeah, here they are. Now the standings will be a little larger than I would normally like, but I don't care that much about it as much as I care about the reinforcement of the base board. Okay, there's the first one. And then I'll put the second one on. Okay, so here we go. Now, I can close this gap even more if I want, but that's just a single NAS right there. I've got what I need, a RAID 1 paired SSD drive matchup, that which will then go into a Raspberry Pi with ZFS and a NAS head, and voila, I've got myself some storage capacity, which I'll build that in the third installment of this process. But what I might do, actually I might choose to do this, is I might reduce the standoffs even more, because I still have, if you look at the gap on this, it's still kind of a little wide gap. I can take at least another 1/4 inch out of that equation and, shrink it down even more. But you can imagine, 3 of these, set up for a RAID 5 configuration or, a stripe set parity configuration. And that would work just as effectively as well. So with that being the case, it's just about shrinking it down to a tighter formation. Your only overhead is the adaptive cabling, which is on the back side. And then if you've got a 3D printer, what you do is you'll build a housing that's very tiny. I mean, we're talking 3 inches, 4 inches tall, maybe 4.5, 5 inches long, with the bus outputs right here. You just can't beat that. So, is it fast? No. Is it NVMe? No. SSD doesn't run that fast in this footprint, nor would ever an NVMe do as well. When you look at the nature of the Pi, you're not doing it because you've got a bus architecture that can support the high bandwidths of such high performance things such as SSD drives and NVMe's. You're doing it because you just want to shrink this sucker down. And if you do the math on this, look at that. That blows everything out of the water. Now, this is a case housing, mind you. And, you can get a different case housing if you like. For instance, you can have a black case housing like this. And, or you can have a different variation of the glass housing. This one's a little thicker and a little wider for the Raspberry 4. But the point is, this guy right here, off to its USB hub, to a single USB connection to this guy, we're done. So you can toggle this somewhere up high inside your enclosure or in a housing or something like that. But when I finish, I'll bring the whole thing to you in a complete picture of what it'll look like, including the cable hookup. Okay, so I paused the video for just a second to show you how cool this can really become. Now you guys remember seeing this before, right? See how small it is compared to a 2.5 inch standard size? And look what I did here. I have a very small standing USB output set here. I've got the SSD drives here, 5 of them. So I can do RAID 5 with a parity spare. I can do that if I want. Now, I will say again, I said earlier in this video that, when you do this kind of stuff, you're going to avoid the warranty of the manufacturer hardware as it's standing is. So when you open this up, there's a little seal inside that tells them that you've opened it up and taken it out. And that's okay because, these aren't that expensive. These are like $20 a pop. But the whole point of this process is to show what this thing could be potentially. And you compare that to a Raspberry Pi. Look how tiny that is. Now, there is some play right now in the spacers because the spacers are pretty small. See how small they are? So I'm going to be putting washers in there to shore that up. And when that happens, these will be evenly spaced and properly separated correctly. And I'll probably put a small membrane between them just to help, improve things. Also, the membrane would be there to create an airflow. So I might just repurpose these old plastic housings to create a little bit of a shelter between each layer if I want. But the cool thing is, in my next video, I'll show you how you take such a tiny little device like this on a support board, right? And like I said, I'll probably just mount it to one of these old, look at that, look at that. It mounts, see, isn't that cool? So once I tighten this up, and when it gets tight, you'll notice that the spaces will break out correctly. And that's it, guys. That is your 5-drive SSD super small format setup, which can allow you to do quite a bit in regards to getting to that next place, right? And I'm putting this in right now just to shore this up so it is solid. Now I'll talk to the stuff which I used. I went to AliExpress to get my my circuitry boards. And I went to Newegg and I got my spacers, the little hex style space nuts which are out there. I'll try to put them in the link of this video when I prepare it. And it's kind of like a Lego strategy. You don't have to have screws, mountings, molded, and printing stuff. You don't have to do any of that. You can keep it simple, sweet, and right to the point. And that can give you everything you want to do and in a very fast format. Now, another thing you'll need to also have are what's called plastic or paper washers. The washers are just there to gap up the smaller gaps that you can't quite close completely when you secure your unit. So here it is. Look at that. I just made this. 15 minutes. That's it. I just created this little gadgetry setup here. Like I said, I ordered the 2.5-inch case housings, which are these guys. And then I pirated what I wanted out of it and avoided the warranty, of course. And I put that over here. And then, of course, I've got my setup here. And I bought some fairly cheap hard drives, SSD-wise. They had the I/O I want to see. Bought them, emptied them, took their SSD drives out, and I tiny formatted the whole bloody thing. Now, with that being the case, the next thing you might want to consider doing is looking at the cabling. Now, yes, there'll be 5 C-class cables coming out of the back of this, but that's why we have shrink wrap, right? So you can slip all 5 of these through and put a binder in here in the middle. And by doing that, you're combining these cables up as a group, and you're creating basically a pseudo USB trunk of sorts. Now, it's still isolated. There's no sharing between wires, but as you double them up, their availability and access to the back of the port system is working just fine. Now, with that being said, also understand that your USB hub is also very important. I don't recommend that you use what's called an independent hub. That means it relies on the independent power source of the, in this case, the Raspberry Pi for power. Not a good idea. Instead, I recommend that you get yourself a class USB 3.10 or standing, such as this. It has your normal power in, which goes to the wall, and you have your C3 output here, which will go to an A-class connector over here. And what that does is it gives you the ability to have all the totally required power you need, independent of the actual logic board that would be using the drives themselves. So you can put a small piece of shrink wrap right here in the middle, and this becomes a trunk. And then that helps control the situation. Now, you have one cable going out from the USB of your Raspberry Pi, going to your hub. That's it. No other cables are required. Have your normal connectivity set up or Wi-Fi, and start staging ZFS. So what I'll do here is, in my next video, I'll talk to that staging process. Now, 2 very important things I want to say here. One, I give you all respect that you know a certain level of IT, integrated technologies. When you don't know it, you need to just stop. Take a break, do some research, understand what you're working with, then go forward again. Now, sometimes you're going to come across stuff that is going to throw you for a little bit of a loop. Or you would say, why would he, destroy a perfectly good hard drive just to have a smaller format of a hard drive? If you're not comfortable with that, then I say stop again, take a break, and reevaluate, if you want to do these kind of things, because frankly, I'm doing it for fun. The next thing is, you also want to be very careful. You may or may not totally understand everything you've got here, and you might go overboard. Like, for instance, I've seen people do this. They'll put really large heat sinks on small microchips and think great things, and it just doesn't happen. If you're going to use heat sinks that are for like a Raspberry Pi, but you want to put it on your SSD cards, like I show here in this particular format, you want to be careful. You want to use very thin heat sinks that all they do is just broaden the spectrum of the surface area so the heat can do what it can do. The key thing here is when you put it back into its home, it doesn't interfere with the next unit, because some of these heat sinks can be pretty large, technically speaking, even though they really technically aren't. Let me see if I got that right. Yeah, there we go. And the space, as you can see, is gapped pretty well, so as they stand on their own, they just don't touch. That's a good thing. There are heat sinks in here that you can put on that will definitely push the space out to the place where it isn't going to work. So those are for like the processors of a Pi unit itself. And you know, it isn't a really great idea to put, you know, a really large heatsink. See how high that is compared to a reduced format heatsink, which is basically, let me show you what it looks like. Here's one right here. This is a reduced profile heatsink. As you can see, it's copper, and on the back it's got the thermal stick pad on it. You peel that off, and as you can see, it's very thin, but all it does is increase the surface area that the silicon chip is working with to add just a little bit more dissipation effect. Now, if you know anything about SSDs, and I've had lots of debates about this, heat is important. Heat does have an effect. But when you're looking, sorry, I'm dropping stuff here. When you're looking at a model like this, and it's an open-ended model with an open-ended chassis, and yes, it needs to be protected, but because it's open-ended, you really don't have to do much for it. Now, let me give you an example of what I mean. Now, I've had some heavy-duty fights with some of my counterparts in the enterprise industry. This has a lot of heatsink built into it. This is an aluminum chassis set. It has a distribution heatsink inside it. It's pure metal. But right here in this little section right here is the actual chip. Now, I could technically take this apart, pull that chip assembly out, and if I did that, I would have to probably put a decent heatsink on it because these guys get hot. And when you stack these on top of each other, as such, because here you have two of the 100 gig drives, look, there is no gapping there. Hence why they have so much aluminum. Yes, there are SSDs out there that can get really hot, and they're pushing very high volumes, and they're usually short-term life. Don't play with that stuff. Just go out and get yourself some standard SSD drives like this. This is a simple SP style drive set. This is an ASS SP drive, as you can see right there. And they weren't expensive. You know, I'm not doing this. You know, obviously, we can do multiple terabytes here. And this is pretty cool. If you look at it, see, that's a totally independent base right there. And like I said, once I tighten these guys up, they'll straighten up perfectly. And they'll line up correctly and everything like that. I'll have that all prepared when I do the third stage of this video. So, outside of that, you know, I paid $2 or $3 a bag for hex spacers and the hex nut assemblies. I have a variety of sizes, big ones, long ones, short ones, medium ones, ones in the middle, one on the outsides. I bought a couple bags of heat sinks. I have a variety of heat sinks that I could work with. I bought a variety of SP drives. These are the housings for them. I do recommend that you keep these because you never know when you have to flip back over, or you might have to take one of your drives out and so on. These particular drives are only 256 gig drives. That was the mission statement in this particular test, because I don't have a lot of money, right? So I'm just doing this on a poor guy's budget and stay agnostic at the same time. Same thing with your leftovers. These are great spare parts for other things. It is a case housing for a 2.5-inch drive assembly. And even when things don't go as you planned, i.e. your micro connector interfaces, these guys right here, and if you look at them, this is how they look. There's your SATA external. There's your LSATA style reduced format right there. As you can see that. And you know, this was not a hit. That's okay, because I'll use it for something else. So I just throw them in a bag here, and I'll keep them for future use. The nice thing about these guys, if I ever wanted to go this route, I could really shrink the format even more by a 1/2 inch. Because if you look at the gap on this, there's quite a bit of distance here on this controller board. But I have to have the controller board to make this work, so I don't have a choice. Now, the other thing is, as you noticed, I bought other variations which I could work with, and I'm still contemplating working with them in different ways to get what I want done. Specifically, for instance, if I want to pair up a drive set like this, as you can see here, you see the format there? And of course I can give these out to my sons because they're both IT guys too. and they can absorb this hardware and repurpose it as well if I wanted to. But the whole point of this is, you see, this standing connector edge is pretty simple. I mean, it's just take a drive set, you know, as a, like for instance this little GFP2, and you can insert this guy right in, and you're done. Great diagnostic hard drive looping. It's got everything it needs. Just need to put it on a powered USB hub for best effect, and it's pretty sweet. So if you put two of these together, as such, and again, you could create your own standing format for, you know, a device setup. You could mount these in a retainer box, run these to a multiple pair of USB ports, and you could have like 20 or 30 of these all set up, no more than 27, of course, to give you what you're wanting. And it would also offer another way of doing stuff, pigtailing and so on and so on. The only problem is these are still just too big, right? So you got to experiment, and it never fails. When you experiment with one thing, it turns into something completely different as you're going forward. So with that being said, this is the video talking to the physical configuration of that tiny little NAS solution footprint that's out there. And I started this a couple months ago to get us to this place now. The direction you can go from here, matter of fact, I wouldn't be surprised if some of my counterparts who watch my videos will go out and build this before I do my part on the Pi, because I only have so much time to do stuff, and they might come up with some version of this variation that is really awesome. You know, I say kudos to you guys. This isn't about taking credit for anything. It's about getting your brains actively involved into new ideas, taking old stuff, reinventing it into new stuff, and turning it into something like it really needs to be. Something innovative, something that can recycle our technology, turn it back from trash into treasure, and give us another avenue to learn and grow from. That's how you get the best bang for the buck in technology. I'm a big fan of hardware that lasts 6, 7, 8 years at a time. This industry can't take that. They're like, no, you got to be replacing every 3 to 4 years. We just can't stay in business because we can't turn the product over effectively enough to be cost effective. So we need people to kind of burn up their hardware so that they want to come back. Kind of like an Apple Macintosh kind of mindset. That doesn't apply, and that doesn't work, guys. All you're doing is just building piles of trash heap. Some say, hey, at least I have an economy based on that. So no, not really. Not when you realize how much damage you do later when we have to go back to that big pile of trash heap you created so you made profit and have to clean it up. And now it's on us to clean it up because you walked away with the profit. We got the mess. So let's try to avoid that if we can. Take the opportunity to look at old stuff and say, hey, man, maybe I can do something really cool with that. Just like you saw what I did here with some standard formats, tore them apart, put them back together in a whole different way, and transformed it into this new strategy. So with that being said, I'm going to let you guys go. I hope you guys enjoyed this. This is just a brief 1, 2, 3 of what potentially can happen down the road. And we will take it from there. All right. I will let you go. God bless and take care.